In digital electronics, oftentimes we use block symbols to identify circuits that have too many logic gates to keep drawing those out to represent the circuit. And our first example, under our title of bistable devices, is something called the latch. In this circuit we have a set terminal, which is an input. We have a reset terminal, which is also an input. And we have what's known as the Q output, which is for all of these different types of bistable devices, also known as multivibrators. They actually have a stable state of high or low, depending upon how this particular circuit is actually triggered, and how it's set up with data on here. So the first one is known as the set. Set, reset, latch. The next one we're going to talk about is a D-latch. It just has one input to it, and it also has a control signal that runs it, so take a look at that. The D-latch derives its name from a data latch. It's a type of device that's used in a lot of signal transmission for data and digital type signals. It is also kind of a formulation of a basis for different types of what we call transceivers in digital equipment, particularly computers. In this example then, we have the data coming in. It's going to be in the form of a logic 1 or 0. This is called an enable, and on these devices, the enable allows this whole circuit to work. That's one reason why we have these devices with an enable, is so that they can actually, you can have many sets of data going through the circuits and appear at the outputs when we need them. And because this has no complement bar above the EN for enable, it requires a logic 1 to enable this circuit. If I had a bar across it, it would require a logic low to activate this circuit. And depending upon what kind of data is needed, whether inverted or just straight data output, it has both a Q and a not Q in its output. The next type of circuit we're going to talk about is those that have some type of a edge triggering action to them. So let's take a look at these. Again, I'm going to use the D flip-flop. And in this example, I'm not going to use the not Q output, but most of these do have one. But this action is a little bit different from the enable. Enables are just requiring a logic high or logic low. They're level triggered devices. These are edge triggered. Whenever you see this triangle in this device symbol, it means that it requires the edge of a clocking pulse or another type of trigger pulse. Our digital pulses look like this, and in the case of what we're going to have here, we're going to label this the clock. It means that it requires a rising edge or a leading edge of the clock pulse. I'm going to label that. This is the leading edge of that clock pulse. It's also called a positive going transition. It means it's going in the positive direction. This is our actual signal level, being logic low, which is here, and logic 1, which is right here. Now, this particular circuit doesn't require the logic high for any particular period of time. It just requires this leading edge on the clock pulse to be present. It has a very particular type of circuit in this part right here, which enables us to activate on the leading edge or positive going transition of the clock pulse or control pulse going into this device. Again, this takes logic 1 or logic 0, and it transfers it out in the same fashion. It's not inverted. If 1 goes in, 1 goes out. 0 goes in, 0 goes out. So this is pulse triggering circuitry that's being used on these types of inputs. The next example is what we call a JK flip-flop. JK flip-flop is very universal in its applications. It can be used for counters, it can be used for what we call registers. It's used a lot in timing circuits and control circuitry. And it does have an actual stable logic 1 or logic 2 in its output. So it looks like this. J, K, here's the clock going in. And for this particular one, I'm going to use the complement bar above the clock input because a lot of these actually do have, see a little bubble down here, actually use this on the trailing edge of a clock pulse. So when it comes up and goes this way, this is when this particular device will activate. It's on a negative going transition, over the trailing edge of the clock pulse. Trailing edge of the clock pulse this way. Whatever is appearing on these, according to the truth table for this device, it will determine what this is going to have on its output. And that includes something called the toggle mode, where J and K are held high with respect to the clock pulse, and this output changes on every alternate clock pulse. In the negative direction, it will actually change its output. Therefore, this particular device does actually divide the input signal by 2. It's a divide by 2 circuit.